Hi everyone, welcome to lesson 4. So today we are going to discuss about healthcare waste management. Clinical laboratory and college courses that do experimentation, they generate waste that must be properly segregated and disposed of appropriately to avoid hazards brought about by improper disposal. As a worker and a student, we should be able to identify the kind of waste we are trying to produce as well as to follow proper protocols or ways of handling and disposing these trashes. So an equivalent risk will also be experienced not only by the residents of the community but also the animals and environment as well if we do not try to follow the exact steps on how to properly dispose our waste or trash in school or even at home. As a medical technologist who is part of an institution called a laboratory or a hospital and who is also an important member of the healthcare team, we all know that the institution where we are working produces healthcare wastes, either in solid or liquid form. And these types of waste are generated from the following. Number one, diagnosis, treatment, management, and immunization of humans or animals. And then number two, research pertaining to the above activities. Number three, producing or testing of biological products. And lastly, we have wastes originating from minor or scattered sources. For example, dental clinics, and alternative medicine clinic. So basically, it's not only the institution or the hospital or the laboratory that is producing healthcare waste, but also other offices that come in contact with patients and other humans. They also produce healthcare waste. There are 10 categories of waste generated in healthcare facilities. So that's from general waste down to radioactive waste. So as we go on with our discussion for this lesson, we would be able to learn that all the waste being generated by healthcare facilities and even other institutions are classified under different categories based on their characteristics, their sources, and the degree of infectiousness. We start first with the first category of healthcare waste we call general waste. It's otherwise known as non-risk healthcare waste or HCW. This means that this type of waste is not capable of transmitting any infection to the person handling the waste. It's comparable to domestic waste and it's usually dealt with by the municipal waste disposal system. This type of waste is commonly generated from administrative housekeeping functions of the healthcare establishment and also produced during maintenance of the premises. So most of the bulk or the amount of waste being generated in medical institution comes from the general waste. It comprises up to 90% of the waste being generated. We have two types of general waste. Number one, we have the recyclable waste, and number two, we have the biodegradable healthcare waste. So, recyclable waste include your paper, cardboard, non-contaminated plastic or metal, cans, or glass that can be recycled if recycling industry exists in the country. And then under biodegradable healthcare waste, we have leftover food or garden waste that can be composted. So, again, general wastes are not capable of transmitting infection to the person handling them. The second category of our healthcare waste is what we call infectious waste. So these types of waste were clinically assessed by a medical practitioner or veterinary surgeon or anyone who is part of the healthcare team who has seen or dealt with a patient in a hospital institution. So these types of waste have the capability or capacity to transmit infectious agents to humans or animals. Waste of this kind is typically generated in the following places, like isolation wards of hospitals, dialysis wards or centers for caring patients with HIV or those who are infected with any of the hepatitis viruses, pathology department, operating theaters, We have medical practices and laboratories, which mainly treat patients suffering from diseases specified above. So those are infectious wastes. Examples of infectious wastes that are generated in specific departments of the hospital are the following. We have cultures and stocks from laboratory, especially in the microbiology section, because this section houses the cultures and stocks of causative agents that are infecting our patients. And then we have surgery and autopsies from infectious patients. We have blood from patients contaminated with HIV or viral hepatitis, since HIV and the other um, types of hepatitis viruses are bloodborne pathogens. We also have feces from patients infected with typhoid fever, enteritis, and cholera. Well, by the way, guys, the causative agents for typhoid fever, enteritis, and cholera are not the same. Okay, but all of them are infectious, especially if the bacteria is already found or can be cultured from the fecal sample of the patient. Next, we have respiratory tract secretions from patients infected with tuberculosis, anthrax, rabies, and poliomyelitis. So, when we see respiratory tract secretions, that includes the sputum coming from the patient. We also have waste from hemodialyzers like um, dialysis equipment, including the tubing and filters, disposable sheets, linen, aprons, gloves, or lab coats contaminated with blood from the patient. Infected animals from the laboratory and instruments in contact with infectious patients or animals. So, for example, you were asked to collect sample from a patient with HIV, or you are a nurse who is assigned to change the IV of a patient infected with HIV. So those are examples of infectious waste. The next category of healthcare waste is what we call the pathologic waste. So these waste comprises non-infectious human body parts, organs, and tissues. So some examples are the following. We have tissues, removed organs, amputated body parts, human fetus, placenta, and also animal carcasses. So those are examples of pathological wastes. The next type of healthcare waste is very familiar to all of us, the sharps. So sharps are all objects and materials that are closely linked with healthcare activities and pose a potential risk of injury and infection due to their puncture or cut property. For this reason, sharps are considered as one of the most hazardous wastes generated in the healthcare facility and must be managed with utmost care. So, of course, our examples for sharps are the following. We have all types of needles, all types of hypodermic needles. We have broken glasswares, ampules, saw, knives, infusion sets, scalpel, blades, lancets, nails, and even vials without content. So, this is an example of an ampule. So our ampule are usually containers for vaccines or medicine. So it's made of glass, and once it gets broken, that's the time it becomes a sharps hazard, or is a source of a sharps hazard. And then we have the amputation set. Of course, if we want to remove a certain part of the body, we have to use the amputation set. And it's usually composed of sharp knives, scalpel blades, and even saw. Okay, so those are parts of sharps. The next category of healthcare waste is the pharmaceutical waste. So this category of waste comprises expired pharmaceuticals or pharmaceuticals that are unusable for other reasons. Example, the callback campaign. A drug recall occurs when a prescription or over-the-counter medicine is removed from the market because it is found to be either defective or potentially harmful. Sometimes, the makers of the drug will discover a problem with their drug and voluntarily recall it. And then, examples of pharmaceutical waste include your expired, unused spilled contaminated pharmaceutical products, drugs, vaccine, or sera. The next category of healthcare waste is the genotoxic wastes. These wastes are highly hazardous and may have mutagenic, teratogenic, or carcinogenic properties. When we say mutagenic, it means that the agent can cause irreversible and heritable changes or mutations in the cellular genetic material called the DNA or the deoxyribonucleic acid. Teratogenic means any agent that can disturb the development of an embryo or fetus, and it may cause a birth defect in the child or halt the pregnancy outright. And lastly, when we say carcinogenic, it means the agent is cancer causing. Genotoxic waste may include certain cytostatic drugs, vomit, urine, feces coming from patients treated with cytostatic drugs, chemicals, and radioactive material. Cytostatic wastes are generated from several sources and can include the following: contaminated materials from drug preparation and administration, such as syringes, needles, vials, and packaging. By the way, cytostatic drugs that were mentioned in the previous slide pertain to cytotoxic drugs that are used to destroy cancer cells. So their mechanism is to inhibit cell division and in this way cause cancer cells to die. These drugs are usually administered during chemotherapies of cancer patients. So moving on, we have under genotoxic waste still, we have outdated drugs, excess leftover solutions, and drugs returned from the wards. So again, the waste that are classified under genotoxic waste are the urine, feces, and vomit from patients, which may contain potentially hazardous amounts of the administered cytostatic drugs or their metabolites, which should be considered genotoxic for at least 48 hours or 2 days and sometimes up to 1 week after drug administration. The next category of healthcare waste is known as chemical waste. So these are discarded solid, liquid, or gaseous chemicals from diagnostic or experiment, cleaning, housekeeping, and disinfection procedures. Chemical waste from healthcare may be hazardous or non-hazardous. In the context of protecting health, it is hazardous if it has at least one of the following properties. If the chemical is toxic, corrosive, flammable, reactive, and genotoxic, it is classified as a hazardous chemical waste. But if it's non-hazardous, it means that the waste consists of chemicals with none of the above properties. For example, we have sugars, amino acids, and certain organic and inorganic salts. Then we have wastes with high heavy metal content. So these types of waste are a subcategory under hazardous chemical waste. They are highly toxic, especially if a person is directly exposed to the waste containing the heavy metal. And not only to the person, but this type of waste is also hazardous to the environment. Examples of these wastes are mercury spill from thermometers or BP app, and dental residues. We also have lead from X-ray radiation in diagnostic tests, arsenic from drugs, and cadmium waste from discarded batteries. That's why it's not advisable to discard unused batteries to the environment because it may cause leaking and the cadmium which is present in the battery may leak in the soil and that could cause environmental pollution or it may be detrimental to health if someone is exposed to that area where you discarded your batteries. Next, we have pressurized containers. So these type of waste include pressurized cylinders, cartridges, aerosol cans, that may contain residues, whether inert or potentially harmful. Gases inside pressurized containers should always be handled with care because these containers may explode if you expose them to open flame or when you accidentally puncture them. The last category of healthcare waste is the radioactive waste. So these are liquid or gaseous materials from radioactive substances, and they are produced as a result of procedures such as an in vitro analysis of body tissue and fluids, or in vivo imaging and tumor localization. They can also come from fecal or urine specimens of patients under radiation therapy, or residues of radioisotope studies in the laboratory. Individuals who handle radioactive waste must be careful and must follow the correct protocol in disposing this type of waste, because too much exposure to radioactive waste can cause cancer, cardiovascular diseases, vomiting, diarrhea, headache, rapid heartbeat, body malaise, and even damage to nerve cells. So, extra care must be taken by a person or an individual who is going to handle radioactive waste. So we're done with the different categories of healthcare waste. Now we go to the sources and composition of healthcare waste. We have our healthcare waste generators. So our healthcare waste generators include healthcare facilities, institutions, business establishment, and other similar healthcare services with activities or work processes that generate healthcare waste. So these include number one, hospitals, like your primary, secondary, and tertiary care hospitals, or we also have university hospitals, general hospitals, or district hospitals. Those are examples of institutions that are healthcare waste generators. You also have infirmaries. Third, are birthing homes, and we also have drug manufacturers. We also have laboratories and research centers, and under this are the medical and biomedical laboratories, nuclear medicine lab, medical research centers, biotech laboratories, blood banks and blood collection services, animal research and testing. We also have dental prosthetic lab, drug testing laboratories, and HIV testing laboratories. Other healthcare waste generators also include institutions such as drug rehab center, schools of radiologic technology, training centers for embalmers, medical schools, medtech intern training centers, nursing home centers, dental schools, and even mortuary and autopsy centers. We also have clinics like medical, surgical, ambulatory, alternative medicine clinics, dialysis, dental, healthcare centers and dispensaries, and veterinary clinics. Now let's go to the waste composition of the different waste generators. So waste composition is often characteristic of the type of source. So for example, if the different units within a hospital would generate waste, they would have the following characteristics. For example, for medical wards, in medical wards, it's mainly infectious waste such as dressings, bandages, sticking plaster, gloves, disposable medical items, use hypodermic needles and intravenous sets, body fluids and excreta, contaminated packaging and meal scraps, and also general waste. And we also have waste generated in operating and surgical wards, but usually the waste generated from this ward are general, pathological, anatomical, infectious, and sharps wastes. For other healthcare units, most of the waste generated are categorized under general waste with small percentage of infectious waste and sharps. For laboratories, that's mainly pathological, infectious waste. We also have sharps and some radioactive and chemical waste. A radioactive because in one of the sections in the laboratory, which is immunoserology, there are tests that make use of um, immunofluorescent dyes that are radioactive, and we also have chemical waste because of the reagents that we use in our tests. For pharmaceutical and chemical stores, we have pharmaceutical and chemical waste and also general waste, and in support units, we have general wastes only. Since there are different categories of healthcare waste generated by different institutions, the Department of Health has devised or establish a color coding scheme that must be used to properly dispose the different healthcare waste to different color coded containers or bins. So they are sorted into color coded bags or containers for easy identification of the waste. According to DOH, non-infectious dry waste must be disposed in black-colored containers. Non-infectious wet waste like kitchen and dietary waste must be disposed in green-colored containers or bags. Infectious and pathological waste must be disposed in yellow containers. Chemical waste, including those with heavy metals, are placed inside yellow containers with black band. Radioactive waste are placed inside orange containers. And lastly, sharps and pressurized containers are placed inside red-colored bags. So this slide shows us the different color-coded receptacles as mandated by the Department of Health to contain our healthcare waste, and most of them have the biohazard symbol indicating that what's inside a container is highly infectious or can transmit infection. So these are the different color-coded containers. You have the black, the green, and the yellow. So each one of them has a specific healthcare waste that must be disposed. Now we go to the basic steps in handling waste. So under this, we have two important steps. We have the minimization and the segregation of waste. Minimization is defined as preventing or reducing generation of waste through an emphasis on source reduction and recycling. This step has many benefits, including source reduction, which means measures such as purchasing restrictions to ensure the selection of methods or supplies that are less wasteful or generate less hazardous waste. Another benefit is recyclable products. Use of materials that may be recycled either on-site or off-site. And lastly, good management and control practices. If we try to apply this one, particularly to the purchase and use of chemicals and pharmaceuticals, then we can achieve minimization in our healthcare facility. The next step in handling waste is segregation. This is an important step to waste management. These are the following reasons why we have to take waste segregation seriously. First is that it minimizes the amount of waste that needs to be managed as biohazardous or hazardous. So always remember that if you're going to mix non-infectious waste with infectious or hazardous waste, that renders the combined amount as infectious or hazardous respectively. Second reason is to generate a solid waste stream that is easily, safely, and cost effectively manageable through recycling or composting. Third reason is to reduce the amount of toxic substances released to the environment through disposal of general waste. And lastly, it makes it easier to conduct assessments of the quantity and composition of different waste streams, thereby allowing healthcare facilities to obtain baseline data, identify options, determine waste management costs, and assess the effectiveness of waste minimization strategies. Now we'll tackle about waste handling, collection, storage, and transport of our healthcare waste. These are also significant undertakings in the proper disposal of healthcare waste that must not be underestimated. The spread of infectious diseases are greatly prevented when wastes are properly handled, collected, stored, and transported by individuals who are assigned to do the job. For the collection and on-site transport, in order to avoid accumulation of waste, it must be collected on a regular basis and transported to a central storage area within the healthcare facility before being treated or removed. So remember that our hospital or our institutions are made up of several departments. There must be a scheduled collection of waste from each department, and all these waste must be stored temporarily in a storage area within the facility before they are being moved to another location. The collection must follow specific routes through the healthcare facility to reduce the passage of loaded carts through wards and other clean areas. And this is also to prevent exposure of individuals that are residing in each of the department to the exposed collected waste. The carts should be easy to load and unload. Number two, have no sharp edges that could damage waste bags or containers or to cause harm to other individuals. And number three, it must be easy to clean. When handling waste or when an assigned person is tasked to collect waste from every department, great care must be taken because some of the waste generated by some of the departments have sharps in them, and usually the most important risks are linked with injuries that are associated with sharps. So when handling healthcare waste, the sanitary staff and cleaners should always wear their own PPEs or protective equipment such as overalls or industrial aprons, boots, and heavy-duty gloves. For the basic steps in healthcare waste handling, for non-infectious waste, remember that our non-infectious waste are categorized into dry and wet. So our wet non-infectious waste are the kitchen waste, and our dry non-infectious waste are bottles and cans, and we also have papers and carton. So all these wastes, they are placed in their appropriate color-coded containers, and they are placed in the garbage holding area, which is located inside a healthcare facility. And since these types of waste are non-infectious, meaning they don't transmit infection, no treatment is given to these types of waste. So collection off-site, your kitchen waste could go to hog dealers and piggery owners. It can be used to feed their animals. And then your dry non-infectious waste, they can be given to junk shop dealers for recycling. Okay, so and also your kitchen waste can also be placed or used for composting, or it can be created to become animal feeds. So those are ways on how to dispose and reduce your non-infectious waste. For aerosol and pressurized containers, we have to remember that these types of waste are quite dangerous because we have to avoid puncturing them or exposing them to flame because they might explode. So these types of waste, they have to be placed inside red colored containers or bags, and they have to be placed in a designated storage area, which is still located inside the healthcare facility. For the aerosol can, since we have to reduce its size, we have to crush the aerosol can, and it must be collected by the municipal collection system. And these types of waste are dumped in the landfill. Whereas for pressurized containers like your oxygen tanks, um, the supplier of that oxygen tank, they collect these pressurized containers, and it's already the job of the company to dispose these kinds of containers. But we also have to remember, guys, that for pressurized containers like oxygen tanks, they can be actually reused. Like you just have to refill it with the appropriate gas, and then you can order the same pressurized container from that company, or maybe that company is supplying the hospital with that kind of pressurized container. So that oxygen tank can actually be used, can be reused. So it's not a problem in especially disposing the container because it can be reused. But for aerosol cans, so for example, like Lysol, it's difficult for it to be reused because once it gets used up, you really have to discard the container. But you have to remember that again, you don't need to expose them to flames or puncture them accidentally because they might explode. Okay. So how about for infectious waste? So our infectious waste are indicated by the biohazard symbol. So remember that when it has a biohazard symbol, meaning to say it has the capacity to cause infection if you are exposed to it. So our infectious waste, they are placed inside yellow colored containers or bags, and before they are totally disposed of into the landfill, they have to be placed in a garbage holding area. Now, our infectious waste, since they have pathogenic microorganisms in them, they have to undergo treatment. And when we say treatment, we have to inactivate first our microorganisms that cause infection before the waste gets collected by the municipal collection system and finally being dumped into the waste disposal or the landfill. For the treatment of our infectious waste or even some of the healthcare waste, I will be discussing most of them in the later portion of the presentation. For sharp waste such as used needles, broken glasswares, ampules, and used scalpel blades, they have to be placed inside puncture-proof containers that are labeled as sharps with a biohazard symbol, and they are temporarily stored in the designated storage area before they undergo treatment. So the purpose of treatment here is to inactivate again any possible pathogen that can cause infection. Since most of the sharps use, especially used needles, they have visible blood on them, and this blood may contain bloodborne pathogens. So it has to be inactivated through non-burn technologies or by the use of chemical disinfectants. If the treatment is non-burn technologies like pyrolysis and the use of autoclave, sterilization of the sharps waste is achievable. And once they are sterilized, they can be collected by the municipal collection system and can be discarded into the landfill. However, for sharps that are chemically disinfected, or that's the treatment being used, they don't need to be collected by the municipal collection system. All you have to do is to bury the sharps in the soil, okay, with cement. Okay, the purpose of the cement here is to prevent people from scavenging or like, you know, getting harmed by the sharps or the used needles or scalpel blades. So you have to make an intact product from cementing the used needles and sharps or blades. Okay. Then for the expired pharmaceutical waste, like your expired medicines, vaccines, or sera, they have to be placed inside yellow containers because they are considered as um, infectious waste, and they are also placed in designated storage areas temporarily, which is still located inside the healthcare facility. And then usually this pharmaceutical waste, the companies who are manufacturing or supplying these medicines or vaccines or sera, they are the ones who are responsible for collecting this type of waste, and the disposal is also made by the company. For radioactive waste, these types of waste are placed inside orange-colored containers or bags, and then they are temporarily placed in the designated storage area. For their treatment, they undergo delay to decay, and then our radioactive waste are collected by the supplier. So it's the job of the supplier to dispose these types of waste. For pathological waste, such as your tissues, remove organs, placentas, amputated body parts, they are placed inside yellow colored containers because they are also considered as infectious waste. And before they are totally disposed of, they are temporarily stored inside refrigerators. So for the treatment of these types of waste, they undergo three types of treatment: either cremation, the use of non-burn technologies, and the use of chemical disinfectant. So for pathological waste that are cremated, the ashes that result from the process are collected by the municipal collection system and are dumped in landfills. Then for chemical disinfectant, which is another treatment, if the pathological waste is treated using a chemical disinfectant, either the result of this process or treatment or the pathological waste will have to be placed inside concrete vaults or buried underground. For the disposal of chemical waste, they are placed inside yellow-colored containers with black band, and before they are totally disposed, they are placed temporarily in a designated storage area. Our chemical wastes are classified into two, the hazardous and the non-hazardous chemical waste. For non-hazardous chemical waste, there is no need for treatment, so they are flushed directly in the sink or under the drain. And for hazardous chemical waste, they have to undergo treatment such as the non-burn using non-burn technologies. Once they are finished performing the treatment, the city or the municipal collection system collects the chemical waste and they are off for recycling. A hazardous chemical is recycled if it is used or reused as an ingredient in a process, reclaimed or used in a certain way, including in a manner constituting disposal and burned for energy recovery. When we say use constituting disposal, it is recycling that involves the direct placement of wastes or products containing wastes on the land. Burning for energy recovery is recycling that involves burning a hazardous waste for its fuel value, either directly or when it is used to produce a fuel. Now we go to our waste receptacles. So our waste receptacles are containers for our healthcare waste, and there are many kinds of receptacle available for the storage of our healthcare waste, and they come in different sizes, forms, and even capacity. And we always have to make sure that before we discard anything inside the receptacle, it should be properly lined with the appropriate colored plastic or bag, because that will tell us that what kind of waste goes or gets inside the receptacle. So in the left portion of this slide, these two refuse receptacles here, these are used for general waste with plastic bag cover. And on the right side, you have your refuse receptacle for pathological waste lined with heavy gauge plastic bag and cover. Why heavy gauge? Because remember that for pathological waste, that is, or the waste generated from that are your remove organs, amputated body parts, placenta, and even animal carcasses. So they have to be placed inside leak-proof plastic bags and containers to avoid leaking if there are even fluids um, included in the disposal. Another type of waste receptacle is the foot-operated lid container refuse receptacle, which is lined with heavy gauge plastic bag with cover. And this is found usually in infectious wards. So for health practitioners who are assigned or working in an infectious ward, they don't need to use their hands to manually open or remove the cover of the receptacle. They can use their foot to press the yellow portion of the receptacle, and automatically the lid will open and they can discard directly anything that they are holding that is considered infectious or waste. And then we also have another receptacle here, the refuse receptacle for sharps with heavy gauge plastic bag and cover. So sometimes our sharps container are not directly placed inside puncture proof containers. They are placed inside plastics, and usually um if it's really time to discard these types of waste, especially the sharps, use um they need to use the forceps to segregate sharps from non-sharps types of waste and then place them inside puncture-proof containers. For radioactive and chemical waste, they can also be stored inside boxes or wooden boxes before they are totally disposed of. Now, these boxes should be properly labeled with the name of the waste present inside the container. And also for chemical waste, if the chemical waste are placed inside plastic bottles or glass bottles, they have to be covered tightly to avoid spilling, just in case, for example, the transport of the box is not properly done. So to avoid spilling of the contents inside a container, they must be properly covered or tightly covered. For the storage of healthcare waste, after they are collected, they must be stored in waste storage areas until they are transported to a designated offsite treatment facility. The storage areas are marked with warning signs such as caution, biohazardous waste storage area, unauthorized persons keep out. So only people who are allowed or have access to the storage area should be permitted to go or get inside a facility. Storage areas should be located within the establishment or research facility, and its location must be away from patient rooms, laboratories, hospital function, operation rooms, or any public access areas. Waste bags or containers should be stored in a separate area, room, or building of a size appropriate to the quantities of waste produced and the frequency of collection. So if you are working in a big hospital, of course, the storage area for the healthcare waste must also be big, because it is expected that if a big hospital has many departments, so much waste can be generated in each department, and the storage area should be able to accommodate all the waste being generated by these different departments. In cases wherein the healthcare facility lacks the space, daily collection and disposal should be enforced. So what are the requirements for storage facilities? We have the following. Number one, the storage area should have an impermeable, hard standing floor with good drainage, and it should be easy to clean and disinfect. And this is in relation to number two, there should be constant water supply for cleaning purposes. In cases wherein healthcare waste containers have leaks, so you can easily clean the spills using water, and the purpose of the drainage is to not accumulate water in the storage area. Number three, the storage area should allow easy access for staff in charge of handling the waste, and he or she has the key um, to gain access into the storage area. That's why in number four, there should be possibility to lock the storage area to prevent access by unauthorized persons. Number five, easy access for waste collection vehicle is essential. The storage area is where the collection vehicle will get the healthcare waste to be brought to the landfill, sanitary landfill. And number six, there should be protection from sun, rain, strong winds, floods, etc. Number seven, the storage area should also be inaccessible to animals, insects, and birds, especially for rodents, cockroaches. The storage area must be free from these pests, because these pests, they also act as vectors for wastes. So if your storage area is not properly locked, or there are holes in your storage areas where these and small animals can get into, they can actually spread the infection brought about by the waste stored in the storage area. Other requirements for the storage area or facility are the following. There should be good lighting and adequate ventilation. It should not be situated in the proximity of fresh food stored or food preparation areas. So, um, the storage facility must be away from food preparation areas, because most of the time the storage area would smell, and it's not right to prepare food and you are smelling something from the storage area. Number 10, a supply of cleaning equipment, protective clothing, and waste bags or containers should be conveniently located close to the storage area. And this is for use by the sanitary staff, especially if they are going to collect healthcare waste from the different department, and if they're going to change the plastic linings inside waste receptacles, and they should be wearing their personal protective equipment with heavy duty gloves and boots. Okay, so it must be situated just near the storage area for easy access. Floors, walls, and ceilings of the storage area must be kept clean in accordance to established procedures, which at a minimum should include daily cleaning of floor. So even if it's a storage area or it's where we temporarily hold our healthcare waste, it doesn't mean that we just ignore it and do not clean it. It must be cleaned daily because that will prevent inviting pests such as your cockroaches and flies and rodents from getting inside the storage area. Number 12, biodegradable general and hazardous waste should not be stored longer than 2 days to minimize microbial growth, putrefaction, and odors. If the waste must be stored longer than 2 days, application of treatment like chemical disinfection or refrigeration at 4 degrees Celsius or lower is recommended. For on-site transport of healthcare waste, we have to use wheeled trolleys, containers, or carts, and these containers or carts should be cleaned and disinfected daily. All waste bag seals should be in place and intact at the end of transportation. So this is to ensure that no waste will come out from the waste bag once you are trying to transport the waste bag using the wheeled trolley. Specifications for the um, vehicle for on-site transport, it should be easy to load and unload. There should be no sharp edges that can damage waste bags or containers during loading and unloading, and it must be easy to clean. So example of on-site collection vehicles are these photos you can see here on the slide. So we have here on the left side, this is a collector with a hand cart of 300 liters. So that is equivalent to 6 bins times 50 liters, meaning to say that each bin has the capacity to carry 50 liters of waste, and each of the bins must have a plastic bag and a cover. And we also have bins from handcrafts that are emptied into a trailer of 6,000 liters capacity in different coding equivalent to 1 day waste. So one trailer load, or this one, the one you can see on the picture, that's equal to 2.4 tons of healthcare waste that comes from 7,200 people. Okay, so that's the capacity of the on-site collection vehicle. It's quite big and it can accommodate a lot of waste. Another on-site collection vehicle is the first picture we can see here on the slide. So it's a handcraft round body for refuse collection, and it has a capacity of 52 gallons, meaning to say that yeah, it can accommodate 52 gallons of trash, and it can be emptied by dumping contents to the ground. So for easy manipulation of this collection vehicle, just have to use your hands, and then you can push or pull this one so that it would be easy for you to manipulate. And then I think you have seen this one, especially for people who are cleaning the streets. They make use of this sometimes to contain the trash that they have swept on the sidewalk. And then we also have the two bean handcraft with total capacity of 120 to 200 liters depending on the size of the bean, and the beans are emptied directly into a transfer facility as to color coding with plastic bag and cover. Another on-site collection vehicle is this one. This is a 6-bean handcraft suitable for daily collection of hospital waste with plastic bag and cover, and the colors or the linings inside each bin should conform with the color coding, or the trash being disposed inside the bin should conform to the color of the lining or the bag. Total capacity ranges from 300 to 500 liters, empty directly into a transfer capacity. Healthcare waste should be transported through the quickest or shortest possible route and should be planned before the trip begins. So these are the following considerations that we have to know for an efficient and effective collection system route. First is collection should be scheduled either by route or zone, and assignment of personnel responsible for the zone or area must be done. There should also be logical planning of the route, which means to say that if you're going to transport the healthcare waste from one place to another, one should avoid passing the collected package of waste on congested area because this could expose people in the community to the healthcare waste. Collection system route must be laid out from the farthest point of the designated transfer station and as collection progresses towards the collection storage area. So there should be a planned streets or areas where you're going to pass from the collection facility up to the farthest point of the transfer. Next, revised routing plan should be established just in case plan A did not work. There still is a contingency plan, which is plan B. Suggested collection frequency on room-to-room basis is once every shift or as often as necessary. Time of collection, regardless of category, should be at the start of every shift. So, what I have observed in the laboratories where I had my duty when I was a clinical instructor, the sanitary staff there, they usually collect um, the waste early in the morning and after the shift. So for example, if the regular shift is from 8 a.m. to 4 or 5 p.m., they usually collect the waste like 7 a.m. and then they change the linings of the receptacles with new plastic linings, and then they also um, they come back after every shift like 4 to 5 p.m. and where they also collect the waste and change the lining. So that's the routine of most sanitary staff in the hospitals I have rotated. So this illustration is a typical layout of hospital collection system. So as you can see in the illustration, we have the hospital building, and then we have open spaces, and we have the areas designated as C, or the collection points, and the areas designated as T, which is a transfer station. So the collection points are actually the areas where the sanitary staff collect the healthcare waste. And then after they have collected all their waste in the collection points, they need to transfer these waste into the transfer station. So the collection vehicle will have to stop in the transfer station to collect all the waste that the sanitary staff had collected from the hospital buildings. We are now in healthcare waste treatment technologies or processes. So remember in the previous slides I have discussed about the healthcare wastes generated and how they are treated before they are disposed into sanitary landfills or before they are being recycled. They have to undergo treatment, and the reason for that is to remove or inactivate or kill any pathogenic microorganism that is present in the waste that may cause infection to humans or animals. So some of these treatment technologies or processes include thermal, chemical, irradiation, biological processes, encapsulation, and inertization. And you would be able to know each one of them as we progress with our discussion. So we start first with thermal processes. So under thermal processes, we have pyrolysis. So this one, it involves the decomposition of substance and materials in the absence of supplied molecular oxygen in the destruction chamber, in which the said material is converted into gaseous, liquid, or solid form. So after you have exposed your waste to pyrolysis, the waste residues may be in the form of aggregates or slugs, recoverable metals, or carbon black. So these residues are disposed of in a secure facility such as your sanitary landfill. So again, you don't directly dispose or throw away any healthcare waste into the sanitary landfill without letting the waste undergo a treatment. Okay, it must undergo treatment first before you discard or let go of that certain waste. Another treatment under the thermal process is the use of your wet and dry thermal treatment. And under this, we have two, the use of your autoclave and the use of the microwave. For autoclave, it makes use of steam sterilization to render waste harmless. So in using the autoclave, you have to expose the waste or infectious waste to a very high temperature. It's usually 121 degrees Celsius and high pressure of 15 pounds per square inch for 30 minutes or sometimes 1 hour. So it has been used in hospitals for sterilizing reusable medical equipment. In Angelo King, we have an autoclave and we make use of we have two autoclaves. One is for sterilizing like culture plates and other laboratory glasswares, and also making culture media. And the other autoclave is used to sterilize culture plates that were already used to grow bacteria inside the laboratory. Okay. And number two, we have the microwave. Microwave incorporates some type of size reduction device. It involves shredding of waste, and it's done either before or after disinfection. Waste is exposed to microwaves that raises the temperature to 100 degrees Celsius for at least 30 minutes. Microorganisms are destroyed by moist heat, which irreversibly coagulates and denatures enzymes and structural proteins. So once you let the waste undergo or place inside a microwave, it is expected that any microorganism present in that waste um, would be killed because of the high temperature inside the equipment or machine that destroys or denatures their proteins and enzymes. Another treatment technology or process that we can use is the chemical disinfection. So this one involves the use of aldehydes, chlorine compounds, phenolic compounds, and these chemicals are added to the waste to kill or inactivate any pathogens present in the healthcare waste. So this is very suitable in treating blood, urine, and stool. In Angelo King, especially for medtech subjects that make use or deal with blood, urine, and stool, before we totally discard containers containing these samples, we add chemical disinfectant first in the form of sodium hypochlorite. So we soak the samples with the disinfectant before we flush them in the toilet bowl. If possible, waste should be shredded to increase the extent of contact between the waste and the disinfectant, and by increasing the surface area and eliminating the enclosed space. So it is understandable that if your waste is so big, it's so hard for the chemical disinfectant to penetrate your waste. So you have to shred the waste as much as possible to increase surface area um, contact with the chemical disinfectant. Another method of treatment is through biological processes. So this one uses an enzyme mixture to decontaminate healthcare waste, and it requires regulation of temperature, pH, enzyme level, and other variables. So examples of biological processes are composting and vermiculture for treating and disposing of placenta waste, as well as food waste or kitchen waste, yard trimmings, and other organic wastes. So those are some of the healthcare waste that can be exposed to biological processes if we want to eliminate them or dispose them. For radiation technology, waste containing potentially infectious microorganisms are treated using irradiation systems. So this is being commonly used in waste treatment operations. So we have to sterilize the waste by breaking down the DNA molecules of the contaminated organism through radiation. Ionizing radiation is very efficient at DNA disruption, and it requires far less total energy than would be used in an equivalent thermal process. Another method of treatment is through encapsulation. This one involves filling up of container with waste, and then you have to add and immobilize the material, and then finally seal the containers. The process makes use of cubic boxes made of high-density polyethylene or metallic drums that are 3/4 filled with sharps or chemical or pharmaceutical residues. And then what you're going to do is you have to fill up the medium with plastic foam, bituminous sand, and cement mortar. This is very useful, especially if you are trying to dispose of sharps and chemical or pharmaceutical residues. Remember about sharps that you have to treat them first with chemical disinfectant, and then after that you can bury them. Um, Burying here is the encapsulation. You have to add cement so that if someone is trying to, you know, break off any part of the encapsulated waste, he or she will not be harmed because it's already cemented. So again, the main advantage of this one is it's effective in reducing the risk of scavengers gaining access to the healthcare waste. And the last process or technology for treating healthcare waste is through inertization. So this one involves mixing of the waste with cement and other substances before disposal to minimize risk of toxic substances contained in the waste that will migrate into surface water or groundwater. This is suitable for pharmaceutical waste. So for this one, what you're going to do is the pharmaceutical waste, you have to remove the packaging, and then you have to grind the pharmaceutical products and add a mixture of water, lime, and cement. The process is relatively inexpensive and can be performed using relatively unsophisticated equipment. And the typical proportion for the mixture of the water, lime, and cement are the following. So you have 65% pharmaceutical waste. It actually comprises the bulk of the inertization process. And we have 15% lime, 15% cement, and 5% water. So if you try to look at the um, percentages of the proportions for the mixture, water is the smallest among all the components of the mixture. So we are already in the last part of our discussion, wherein we are going to discuss about the four basic waste disposal techniques, such as your flushing down the drain to the sewer system, incineration, a landfill burial, and recycling. For flushing down the drain to the sewer system, this is only applicable for non-hazardous chemical waste. So we start with incineration. Incineration or combustion, it's a type of disposal method in which wastes are burned at high temperatures, and the process eventually converts these wastes into residues and gaseous products. It's used to be the method of choice, but because of the implementation of the Clean Air Act, this method is no longer allowed. We also have the landfill burial or the sanitary landfill, which is an engineered method to keep the waste isolated from the environment, and appropriate engineer preparations must be observed first before the site can accept any waste from different facilities. Some essential elements for the design and operation of sanitary landfill are the following. We have access to site and working areas possible for waste delivery and site vehicles. So remember that the transport vehicles, they collect waste from the different facilities. So once they get into the sanitary landfill, there must be a specific area for them where they can pass through and dump their collected waste. Presence of site personnel capable of effective control of daily operations. So there should be someone who should oversee all of the activities that are happening in the sanitary landfill. Adequate sealing of the base and sides in the site to minimize the movement of wastewater. Remember that if wastewater in the sanitary landfill are not controlled properly, they may leak into other parts of the area where the water should not be found. Organize deposit of waste in a small area, allowing them to be spread, compacted, and covered daily. So our sanitary landfills, although they are big, they are wide, and they can accommodate a lot of waste from different institutions or facilities. If there is too much waste being dumped and not properly compacted or spread, so eventually the sanitary landfill will be full of waste. So there should also be people responsible to spread and compact and cover the um, area where the wastes are usually dumped. Construction of a final cover to minimize rainwater infiltration when each phase of the landfill is completed. So if this area of the landfill is already full of waste and it has been compacted and covered daily, once it cannot accommodate any more waste being dumped into it, there should be a final cover to minimize rainwater infiltration into the site. Lastly, we have recycling. So recycling is collecting waste and processing it into something new. Many items in the hospital can be recycled, such as organics, plastics, paper, glass, and metal. Okay, so remember that there are junk shops that actually buy bottles and papers. Okay, so the hospital can actually sell this to junk shops for recycling. So always remember, guys, that if you are working inside the laboratory, or if you are in Angelo King right now, and we are dealing with different healthcare waste, you have to ask your teacher where and how to dispose the waste if you are unsure. Never pour anything down the drain unless you are told to do so. Decontaminate first all samples with appropriate disinfectant before discarding. And lastly, a waste bottle will be supplied for substances that cannot go down the drain, because these bottles will have to go to the stockroom, and the stockroom personnel will be responsible for storing them properly to be collected by the university buildings and grounds. Okay, so that's it for lesson 4 on healthcare waste management. I hope you have learned something from today's discussion, and thank you so much for listening. I'll see you next time.